Bismillahirrahmanirrahim. How are you, students? Today we will study unit number 2, class 8, subject physics. Today topic is free fall motion. Free fall motion is any motion of a body where gravity is the only force acting upon it. The condition of unrestrained motion in a gravitational field. State of a body that moves freely in any manner in the presence of gravity. So if a body is thrown upward or if a body is thrown in the downward direction, the motion of that body is called free fall motion because the only force which is acting on that body is the gravitational force. If you look to the diagram, you will see that a body is thrown in the curved path. The two-dimensional motion of a body is shown in the diagram. Here the initial velocity of a body is 30 meters per second. The same body have 20 meter per second square velocity. So there is decrease in velocity. There is further decrease in velocity for the same body. And finally it will comes to rest at the maximum height. So from this we can conclude that if a body is thrown in upward direction, its initial velocity will have maximum value. Initial velocity have maximum value and final velocity will become 0. Final velocity will become 0. And as there is decrease in velocity, so acceleration, which is in this case represented by g and is called gravitational acceleration, will be minus 9.8 meter per second square. So I will not write the unit, you will write. 9.8 meter per second square. Meter per second square. So when a body is thrown upward, its initial velocity is maximum, final velocity is 0, and the value of g is negative. So if a body is thrown downward, its initial velocity will be 0, and when it comes down, its velocity increases, and final velocity will become maximum. So when a body is thrown, and here the body is moving in the downward direction, so you will see an increase in velocity. Now you can see in this example the downward motion of an object. This arrow represents the motion of an object. This represents the acceleration, which is positive, and this represents the initial velocity, and it will hit the earth with maximum velocity here. This is the motion of an object, and the height and the different values of velocity is shown in the figure. The velocity at this point, when the body is thrown upward, is 13 meter per second. Initial push given to a body is 13 meter per second. At this point, the initial push is given 13 meter per second. So when the body start downward motion, at the same point, the body will have the same velocity, which at this point. At this point in the upward direction, and at this point in the downward direction, the body will have same velocity. Now in this diagram, here the velocity of a body and here the velocity of a body is same. From this point, the body is lifted. So it will hit the ground with the same velocity the velocity in this diagram, in diagram A and B. This point, at this point, and at this point, the body will have same velocity. Because velocity is a vector quantity, so it will be, if you take positive in the upward direction, it will be negative in the downward direction. Here the free fall motion is shown in the figure. Here the value of g is downward. Here also the value of g is downward. Here velocity is in upward direction because the body is moving in the upward direction. Here the velocity is, the body is moving in the downward direction. So velocity and gravitational acceleration both are in the downward direction. And here both are in the upward direction. Final velocity will be zero. Final velocity will be zero for upward motion. And initial velocity for downward motion will be zero. And if it is thrown with 20 meter per second, it will hit the ground with 20 meter per second. So at this point and at this point, at this point and at this point, both the bodies will have same velocity. In upward motion, if you throw the ball with the initial velocity 20 meter per second, it will hit the ground with the same velocity. Here, in this diagram, different velocity have been shown in figure. The body start from rest, so initial velocity is 0 meter per second. After 1 second, it will become 9.8 meter per second. After 2 seconds, it will become 19.6 meter per second. After 3 seconds, it will become 29.4 meter per second. So after every and each second, there is an increase of 9.8 meter per second because the value of rotational acceleration is 9.8 meter per second. And after 5 seconds, it will be 49 meter per second. So it's only a rough calculation. It changes from place to place. Now the next topic is unit conversion. We have to convert kilometer per hour into meter per second. 1 kilometer is equal to 1000 meter. Kilo means 1000 meter means unit of length. 1 kilometer, kilo is a prefix. 1 hour is 60 minutes and 3600 seconds. 1 kilometer per hour is equal to, in place of kilo you will write 1000 and in place of hour you will write 3600 seconds. So you will get 1 kilometer per hour is equal to 5 divided by 18 meter per second. If you convert 0 kilometer per hour into meter per second, you will multiply with this factor. You will get 0 meter per second. If you want to get the final velocity, if the final velocity is 72 meter per second, 72 kilometer per hour, in place of 70, you will write 72, and in place of kilometer, you will write kilometer per hour. In place of kilometer per hour, you will write this value. Because 1 kilometer per hour is equal to so much second. We will write this value over here. So it will give you kilometer per hour in meter per second. So 72 kilometer per hour is equal to 20 meter per second. The real methodology is you will write 72 kilometer per hour. So 72 kilometer and per hour. Per hour means divide by hour. Here multiplied by 1000 meter divided by 1 kilometer. So 1 kilometer is equal to 1000 meter. In place of 1, it is written 1. Kilo means 1000, 1000. 1 kilo means 1000 meter. So this this term as a whole is equal to 1. This term is equal to 1. 1000 meter divided by 1 kilometer. 1000 meter divided by 1 kilometer is equal to 1. So you can make changes in an equation if it not affect the equality. So 1000 meter divided by 1 kilometer is equal to 1. 1000 meter divided by 1 kilometer is equal to 1. So you can write 1000 meter divided by 1 kilometer. Now here 1 hour divided by 3600 second is equal to 1. So you can make these changes. You can do these changes. So after simplification, you will get 20 meter per second because you will cancel 1000 with 3600 and 72 with also, and kilo is cancelled with kilo, r with r. Here meter will be lifted and second will be lifted. You will get 20 meter per second. Now convert kilometer per hour into meter per second. If you want to convert kilometer per hour into meter per second, you will make division by 3.6. 3.6. For example, we want to convert 180 kilometer per hour into meter per second. Kilometer hour into meter, we will divide it by 3.6. So we will get 50 meter per second. So when 180 is divided by 3.6, if 180 is in kilometer per hour, you will get 50 meter per second. This is the shortest way. And if you want to convert meter per second into kilometer per hour, there you make division. Here you will make the multiplication. You will get the answer. Convert 20 meter per second into kilometer per hour. So here you will write 20 meter per second. So this can be written like this. 20 meter per second is equal to 20 meter is equal to 1 divided by 1000 kilometer. 1 divided by 1000 kilometer, and 1 second is equal to the value of this 1 second is equal to 1 divided by 3600 r. So in place of second we will write 1 divided by 3600 r, and in place of meter we will write 1 divided by 1000 kilometer. So 20 multiplied by 3600 divided by 1000, we will get 72 kilometer per hour after simplification. So this is the end of the today lecture. We will make a little revision. Free fall motion is the motion under gravity. The motion which is under the effect of only one force, and that is gravitational force. Such type of motion is called free fall motion, and the object is called free falling object. And gravity is the phenomena of attracting a body. If Earth's surface attract a body towards its center, this phenomena of attraction is called gravity. So the force exerted by Earth on another object to attract it towards its center is called gravitational force. And the space and region around which its gravitational force can be felt is called gravitational field. This is the motion of an object. Here initial velocity is 0, g is 9.8 meter per second square, and final velocity will be maximum. So when a body is thrown upward, its initial velocity will be maximum. Here, the initial velocity will be maximum, acceleration will be negative, final velocity will be 0. And downward motion, initial velocity will be 0, G will be positive, and final velocity will be maximum. Free fall acceleration is shown in figure. Both upward and downward motion is shown in figure. G will be, gravitational acceleration will be always in the direction of gravitational force. This is unit conversion. And I hope so you will understand it. In the next coming topic, we will discuss it in further detail. So it's today lecture. In the next lecture, we will do the exercise and MCQs. In the next lecture, we will do the numericals also. Thank you, students.